you to JUnit 5. I'm very excited to be talking about JUnit 5 and really automated testing in general, and I'll kind of get into that in a second. But first, as an audience, I want you to ask questions. The purpose of this presentation is to introduce you to JUnit 5. So if you think I'm not being that clear about something, getting a little confused, feel free to ask a question or let me know if you want me to go into more depth. I think we should have some time to be able to have questions. If nothing else, we have like some QA at the end. And of course, feel free to tweet at me at Korando. And then of course, also, this is a link to this slide deck. All right, so a little bit about me, and this will kind of help build the foundation for why I'm so excited to be giving this presentation. So I have 10 years experience. I can say that actually as of yesterday. And during that 10 years of experience, I have worked in some extremely exciting industries of insurance regulation, electronic health records, shipping, finance, and government. So one thing I've long pondered is, why do organizations struggle delivering to production? So like many junior developers, my first task when I started programming professionally was maintaining a legacy application. Now, to anybody here who has experience, developing software, you know exactly what I mean when I say legacy application. For the students here, you will soon find out what I mean when I say that. But needless to say, when I say legacy application, this is all the typical things of really poor design or no design, very outdated technology, and then also a very long pipeline to production. I believe when I first started with my first company, we did about 3 or 4 releases a year. So about 3 or 4 months between each, at least scheduled release. If there was a bug, then we do an emergency release. Everything just goes out the door when there's a bug in production. But what this meant is that after release, there sometimes would be a bug, and then if that change or that bug was caused by a change 3 or 4 months ago, it's going to be very hard to figure out why you made that change or not. So anyways, I kind of got used to this, figure things out, but oftentimes, change in one area cause breaks in others. So then I was part of refactor or rewrite processes. And those would take a few weeks or a few months depending on what we were doing. But that would start off with we're going to fix all the mistakes we did before. And, we would get to production and things would be a little bit better. But, not much. After a few months or a few releases, things are about back to where they were before. So, that didn't answer the question of why we struggled delivering to production. Next, there was, trying to take on new development methodologies like Agile. And so it was very exciting. This is going to revolutionize how we're going to deliver to production. Things are going to be so much better. And maybe it helped a little bit when we're following Agile well, but still things weren't correct. Didn't really answer that question. So a couple years ago, I read a book by Jez Humble and Dave Farley called Continuous Delivery. And then also had a conversation with Marcin Conrad. How do you pronounce his last name? Marcin Jasa. Yeah, I think that's still not correct, I'm sure. But anyways, head of Spring Cloud, kind of talking about automated testing. He kind of really laid into me for not doing enough automated testing. And kind of from that, I realized that automated testing or often lack of automated testing I've seen in industry kind of lies at the heart of a lot of the struggles we face as developers. Automated testing, it gives us 2 really key items. It gives us confidence you're fixing what you set out to fix. So that's kind of called red-green refactoring or test-driven development or behavior-driven development, kind of depending on what you're setting out. But you're going to kind of, create some tests that, lay out the requirements of what you're trying to fix. And then once those tests get to green, okay, you have confidence that, yes, I'm not just saying I actually got this fixed or I actually, implemented this feature. This feature is actually here because we have tests showing as much. It also gives you confidence you're not going to introduce a new bug. If you have an extensive test suite, if you make some sort of change and then run that test suite and you're not getting any test failures, well, okay, at least you're not going to introduce a bug, at least in something you fix. Now, maybe you could still introduce a bug because it broke something that you actually didn't have a test on yet. But then, of course, after release, you add some new tests, you can get increased confidence. And what this allows is a much faster development cadence. Also allows you to refactor and make changes to your existing code, so you never really have legacy code. But I won't say I take full credit for this quote. I just kind of thought it, whatever. But I kind of would say is without automated test, you're already building legacy. If you're rewriting an application and whatnot, and you're not putting automated tests as a part of that, you know, within 3 months or 6 months or a year, it's going to start feeling like legacy. You're not going to want to upgrade to the newest libraries because you don't know what's going to happen. I recently released a new course on Pluralsight, in which, with the Spring particularly, I talk about how to do effective automated testing. If you like this talk, I cover a little bit about JUnit 5 in there. You know, check it out. I would really appreciate that. I'm also going to be doing a bit of a blog series about things I learned about while making that course, and so you can follow there. Actually, I think I should be releasing that first article in that series tomorrow, in which I kind of actually just talk about what I just talked about a bit more in depth. But if you check it out, please get feedback, because I really like to hear what people think about it. All right, so on to the meat of this presentation, JUnit 5. So why do, like, we have JUnit 4, why do we need a new version? So, of course, the goal of any new version of a, particularly new major version of a library, is to modernize. And probably the biggest item within that modernization for JUnit 5 is taking on a baseline of Java 8. JUnit 4 was released back in 2006, and I think it was released just after Java 6 was released, or Java 1.6. So we're talking some pretty old things here. And so a lot has changed, particularly with Java. Probably the biggest reason for kind of starting what would eventually become JUnit 5 is the introduction of lambdas, and we'll kind of look at that later. Another goal was to modularize and then also make JUnit 5 much more extensible. And then finally is backwards compatibility. So, you know, if we upgrade to JUnit 5, if you have test suites of hundreds or thousands of tests across maybe your organization, the idea of upgrading to JUnit 5 and having to immediately rewrite all those tests, well, that's as a non-starter. So, of course, backwards compatibility was very key. And the backwards compatibility goes all the way back to JUnit 3.8. So JUnit 4, you're totally fine. JUnit 3.8, you're good. But beyond that, they no longer have support with JUnit 5. So let's look a little bit more into the modularization and the extensible goals of JUnit 5. And so also one thing is with JUnit 5, so like right now if you bring in JUnit 4 in your Maven or Gradle, that's just one dependency. Well, that's not going to actually happen. You can't go to that dependency and do like JUnit 5.0.0 to upgrade to 5. It's actually multiple dependencies. That's part of the modularity. So like there's 3 major modules to JUnit 5. The first is vintage, and like I said, that's backwards compatibility. Next is the platform, and that's where like the test launcher and all the tooling support for like IDEs and Maven and Gradle is located. And finally, there is Jupiter. If you want to know why it's called Jupiter, it's because Jupiter's the 5th planet from the moon, and then our 5th planet from the sun. And then also coincidentally, it begins with JU. And then when people talk about JUnit 5, this is probably what they're most going to think about, because this is where it's going to be changing how you actually write tests. But then within these modules is actually all the various dependencies, and this isn't an exhaustive list by any means. But yeah, under vintage you would have JUnit 4.2 as libraries. I think that's one moment. Technical difficulties. Okay. Well, if the stream's fine, I can talk loud enough to everybody here. Can everybody still hear me right? Great. Okay. All right. So, yes. So, yeah, JUnit 4.2, JUnit Vintage, and those would be dependencies under Vintage. JUnit Jupyter API, JUnit Jupyter Engine would be dependencies under Jupyter. And then also, this is where the extensibility comes in with like the third party of Spetsky. There's, or Spetsky, I'm pronouncing that wrong and whatever, moving on. But that's where they would live, and that's how it's much more extensible. And then finally, under the platform, that's where, that's what's actually going to be launching the test. That's where tooling support for IDEs and build tools like Maven and Gradle come in. And I like to attribute that this is... Okay. Go ahead. Great. All right. So yeah, platform. That's where like all the IDEs and tools, like I said, IntelliJ, Eclipse, and so on. That's where they hook into. All right. So migrating to JUnit 5. Now's for the live coding fun. So I have a little just demo project here in honor of Joss. It's a reservation system, of course. Not that that's really going to be particularly relevant in this demo. So let's go ahead and just run all the tests in here, which are all built using JUnit 4. And yeah, this will just take a few moments to run here. Not sure why that's all blue over there, but great. So all these tests passed. So the first thing we're going to need to do if we're going to start using JUnit 5 is, of course, bring in the dependencies. And to do that, I'll just simply do JUnit 5. Great. So let's just run these tests again. Let's just make sure bringing in these dependencies doesn't break anything. And we'll see here after, again, a few more moments, everything should pass. Of course, unless the demo gods decide to get angry and start just randomly filling my stuff. Fantastic. The code demo is still successful so far. All right, so yes. So we have been able to at least migrate, bring in all the dependencies to JUnit 5 without causing any regressions on our existing test suite. All right, so back here for just a couple of slides. So we migrated JUnit 5. So now writing tests with Jupyter. So it's a major version change. So that, of course, means they can introduce breaking changes. So some of these changes, and this is, again, a non-exhaustive list, is so instead of the @test annotation being under JUnit.test, it's going to be under JUnit Jupyter API test. Similarly, instead of using the asserts under JUnit.org.JUnit, we're going to use the assertions under org JUnit Jupyter API asserts. No longer is there ignored, now it's disabled, and that brings with it a lot of new functionality we'll get into. Run with rule and class rule will be replaced with extend with. There's before class and before, and now it's much more legible before all and before each, and similar with after class and after all to after each. So, okay, let's take a look at actually running some tests in JUnit 5. All right. So I have this class that's testing the room service impl. And we'll just rename this to JUnit 5. All right. So the first thing is we're going to have to change a lot of these imports that we're using right now. And So we got rid of that, and we're going to keep the rule here for a little bit. We'll show you how to also do some rule migration as well. Or get that as well. All right. So once again, you're going to be using the test under org JUnit Jupyter API. So just make sure you don't accidentally hit org JUnit, because that will be back to JUnit 4. And similarly, again, assertions, not assert equals. And we'll just do a little star here to resolve all those other assertions. So in one big change is how there is exceptions are handled. So there's actually two different ways of handling exceptions in JUnit 4. Actually, while researching for this course, I didn't realize you could actually use rules instead of the expected exception up here to catch or exceptions. But anyways, instead of doing it like expected, like I've usually done here, what we'll have is, and we'll get rid of all this, is there's the assert throws. And this kind of immediately gets into the Java 8 baseline that makes this possible, because it's using lambdas to be able to do these as an executable. So, and then this assert throws will return the exception that's being thrown. So that way I can do room service exception E, and that way I can also then test the message being thrown to make sure that actually matches, not just that the exception itself. So, why is that not resolving? It's imported. Oh, I know. Sorry. I actually had to do a lambda there. There we go. Great. So if I was to run this again, this will pass. Now if I run all of these, the test that's depending upon the rule here, this failed. So let's say you want to start taking advantage of the new features in JUnit 5, but you still have like a lot of rules, and you don't want to have to maybe take that heavy lift immediately of migrating all those rules. Well, luckily again, the maintainers or the committers for JUnit 5 kind of thought ahead on that, and they have offer migration support.
Can I ask a question?
Absolutely.
So what's the advantage of the assert throws?
Oh, so assert throws is
compared to doing it in the annotation.
So like an advantage would be, and here I can go back and kind of show. Where is it? There we go. So here, doing the annotation is like you just have to throw the E out and like read through the message. I mean,
so is it basically because you want to do the assert equals afterwards? And so you have to work around it this way with the try catch, and with the assert throws, you can just assert on the exception, then you can do the other check after?
Yeah. I mean, it's a little bit less code. It's a little bit cleaner, so you don't have to put like this try catch just so I can capture the message. Like I could just, do this, and, it would see the expected exception, but like at least then in this case, I couldn't really test to make sure like the message is there.
Yeah, okay.
So it's just like at least a little bit cleaner.
It is,
yes,
what it
fundamentally comes down to. That's another. Yep, that's a great example. Also, is let's say this actually doesn't throw an exception.
Right.
It would actually still silently pass because I forgot to put the fail there. Yeah.
Oh.
Well, actually, it wouldn't because it's expecting the exception, and I'm then throwing it.
Right.
But yeah, I've ran into that before. All the same, so it's a little bit more straightforward.
Yes.
So you don't run into that.
Cool.
All right. So Okay. So back to the rule migration support. So first, to do the rule migration support, you have to again bring in another dependency JUnit Jupyter migration support. And then back in our test class, you will do at enable rule migration support, and we'll just resolve that. And if we run this test again, or this test class again, we pass. All right, so who has ever ran into an issue in which you have multiple asserts in a test, and you run the test and it fails? And then you fix that first assertion failure, you run the test again, and it fails. Well, once again, this is where an advantage comes in JUnit 5, in which you can actually wrap all these asserts into a single assertion, and then it will tell you all the failures in a single run instead of multiple ones. So and with that, we do assert all. And again, this is depending upon lambdas. So we do that, and just copy and paste that all up here. Got that. And then, all right, yeah, let's actually get some failures for this test then. So we're just going to change everything just a little bit. Whatever. Doesn't really matter. It just needs to be a different value. Now if you rerun this test, save it first. Great. So now we get all these failures right here instead of having to run this test 4 times to get through all of these. And I'll go in and just, yeah, it's a whole lot better for sure. And get rid of that. Oop. All right, so that's our first little taste of writing in JUnit 5. So let's so next, I guess don't really go back to full screen. We're going to be looking at extend with, and then also some of the many new dependency injection improvements that are coming in JUnit 5, that are in JUnit 5 because it's actually released. So here, I'm doing a test on the customer repo. So one thing I would highly recommend, if you are using JUnit, and you're also a Spring project, to then actually use Spring data. It's going to take away a lot of the boilerplate. It's simply just to do like a CRUD repository. You just have to do like interface, and it'll take care of all of that. And it also has ways of like a DSL for doing like simple searches and stuff. I would highly recommend that if you're doing JPA, working with JPA. Anyways, so instead of run with, like I said, that no longer works. We have extend with. And so I'm also using Spring Boot 2.0 and Spring 5, and so that's more compatible with JUnit 5. I think they have some backwards compatibility with JUnit 5 and 4.3. Is that correct, Mark? I think I remember seeing Sam say that. I believe some of that's been backported. All the same, JUnit 5, Spring 5 work really well together, so upgrade to Spring 5 and use JUnit 5 together. Anyways, to do that then, we have Spring extension class, and just resolve those, and then context, configuration, and we'll also need to update all these assertions. So like I said, so after's gone, now it's after each. And star this. Great. So we got rid of all these compilation errors. Let's just give this a run. And that all passes again. Great. So and also what's nice is a lot of like these annotations can be combined. So instead of having to do 2 annotations of extend with and context configuration, you can also, with Spring, just simply do Spring JUnit config. Fortunately, code assist is really slow and buggy, but that works just as well. So another thing you can do now is actually inject parameters directly into test. So you can do like this. Auto-wired. And we can do the repo. Oh. So yeah, we can just directly auto-wire this repo into here. For example, if we have like different repos we want to use for each test, we can do that now. You can even have like qualifiers on there as well for, you know, repo 1, repo 2, and we can run this test again. Once again, the test passes. Let's see, what was the next thing? And you can also do the auto wiring into the constructor. So if I was to put it up here, and all right, so take off these auto-wired here. Again, we can run this test again. It should all pass. Cool. The demo gods are so far smiling upon me. All right, so then another thing you can do, and I'll just actually hop over to this first test class we worked on just so it'll be a little bit easier to read it, is there is also things like test info that's automatically being put into the context when you're running test. That provides like meta information. Oh yes, also I know one other thing is I don't see the particular how it's going to change how people test, but you also no longer have to have public test methods. So you can have just package private, and that also goes for the class. But yeah, that still runs. I guess slightly less typing, but all the same. Then the actual main thing I was going to show here is the test info, and there's a few other ones depending on the type of test you're running. Now we'll show those a little bit later, but we can just do system.out.println and test info here. Run this again. It will give you meta information about the test. So that could be useful maybe for report generation or certain things, or just also to get an idea like why is this test failing. You can possibly toss that test info, get a printout. Now I can't believe I forgot to show this earlier, but this is by far the biggest change coming in JUnit 5. It is the real cloud pleaser. You can now do display name and test so yes, now we can run this, and so instead of test info being displayed here, we have test awesome name. But that's not all. And to anybody who's been following any amount of JUnit 5, you know where this is going. We can now, that's right, ladies and gentlemen, put emojis into our test names. Always a cloud pleaser, but yeah, even displays down a console, displays up here. And it's actually, Sam would probably want me to point out, Sam Brandon, is that they did not aim to support emojis, but in supporting like exclamation marks, they also supported emojis. And actually, there could be a real use case for this. Let's say you're doing some internationalization. For German, you could put like a German flag up there, and for British English, a British or Kingdom flag or American flag for American English. So there is actually some legitimate use cases, if you will. So that's just kind of cool and interesting. All right. Of course. I mean, I always write terrible tests, so it's all poop emojis, anyways. All right. Yeah, I think I covered all I wanted to cover there. So yeah, extend width and dependency injection. Yeah, a lot of improvements there for sure. Next, I'll cover the parameterized test, repeated, and dynamic test. All right. And this is again where actually I won't be able to fully show it here because I just don't have a good example. But so like right now, if you want to run a parameterized test in JUnit 4, you have to do this run with. Now, what if you want to actually set up a context with like Spring Boot or something? You can't do parameterized .class and then Spring Runner .class. You have to do a lot of futzing to actually get that to work. So, but because we can do extend with, or actually, sorry, it's not even doing extending for a parameterized test. And actually, sorry. The first thing you need to do before you can do that is it's another dependency we have to bring in, which is JUnit 5 params. Again, this kind of gets back to the modularization and extensibility that were the two major goals of JUnit 5. But this is how a parameterized test would work here in JUnit 4. We could just run it. In this example, doing for like a reservation system, we have like there's a lot of business rules around dates. Like for example, we need to make sure the start date is before the end date, and then we need to make sure there's dates. They're making sure like correct formats are here. Like I have, there is no February 30th, for example. So that's where I guess just to say if you're not doing much parameterized tests, that's a really good use case for parameterized tests to where there's a lot of potential code paths through something, but the setup is very similar. So instead of having to write out 4 separate test cases, you can put it all in here, and that way if you have any refactoring changes, it's much easier to change it all in one area instead of 4 separate test classes. So anyways, this is what a parameterized test will look like in JUnit 5. In this case, I am using the method source. And to do method source, the name here needs to match some method name in the class. And then it needs to be returning a stream that's also been typed to where you're going to be passing in to your parameterized test method. And again, if we were just to run, and so there's, like I said, I'm using method source, but there's a bunch of different things. There's like CSV source, in which case you can actually just type it directly into the annotation, or you can actually like reference like a CSV file on class path. There's enum source, string source, and I think there's going to be probably more added later. So we can run this, and we get back. And so like these, it's actually not too bad because I kind of went ahead and implemented toString on the test, but we can actually clean up how these test names are printed out. Not that it's really needed here, but it's just good to know. So what you can do is name, and then the argument, or you can put anything arbitrarily in here, but in this case, we're telling it to use the first argument in the method that we're passing in, or we're calling. And if we rerun this again, it's a little bit more nicely printed out. All right. So, and I don't think they really had repeated test. They definitely didn't have dynamic test in JUnit 4. But like, let's say you're just like testing something sequentially. Like, let's say you're just wanting to make sure the generation of IDs is correct. So it's just, and it's going to be serially generated. You just want to make sure that's happening. In that case, a repeated test would work. In this case, I'm just taking something directly from the JUnit 5 guides. But if we run through this, it just runs these tests a bunch of times. You tell it how many times to run, like in this case 10 or 5. You can also change how the names are displayed. You can kind of see it over here in repetition info, or in this case it was German. And then, yeah, so there was test info. If you're running repeated test, you can get the repetition info as well. But yeah, that's this, like a repeated test is if you're doing something sequentially, or, it's a very followed pattern for what you're wanting to do the test, and you don't want to go through the whole process of setting up a parameterized test. Then there's also dynamic test as well. And it's kind of like the similar use case of maybe have a specific pattern you can follow, and you don't want to go through the whole process of setting a parameterized test. So we'll just go back to here, and dynamic. If I spelled that correctly. There we go. All the imports. There we go. And then, yeah, pretty similar. Just kind of running through some tests. This isn't probably the greatest example of what you'd be doing for dynamic tests, but I can definitely see the use. At first, I was kind of confused as to the point of it, but I'm like, oh, there's cases where you want to run through a test a bunch of times, and maybe it's a very set pattern that you don't want to have to manually type all that code in, and that's the use case for dynamic test, and then also repeated test. All right. And oh, yes, go ahead. Oh, absolutely. Mm-hmm.
So with the iterated test here.
Uh-huh. Oh.
With the iterating the test here, does it fail on the first one, like with the asserts from the previous?
Let's find out.
Because I figured this would be useful for testing. You've got a whole data set that are a bunch of different possible cases. You might want to see all the cases that fail.
So no, yeah, it'll actually go through all the tests. That's great. Yeah.
That's cool. Yeah.
Yeah, great question. Thank you for asking. All right. All right. So back to here. Okay, this is actually another really cool thing. So over the past couple of years, I spent most of my time as just a developer or senior developer, and now I've kind of moved into the architecture roles for reasons I don't know. I guess they're desperate at these companies I'm working at. But as architect, you have you're kind of there to kind of help set more guidelines and stuff, and help to make sure maybe make developers' lives actually try to make them easier and follow along certain paths. And then this also kind of goes into another cool article I've recently read. Who here has heard of DRY? Do not repeat yourself, or don't repeat yourself. All right, so really interesting article in which, I think as developers, we have maybe taken that too far into which, if we ever have two similar, classes or methods, we're oh, we have to refactor that into a single one. But originally, DRY was about having a single source of knowledge or a single representation of something. So sometimes it could actually have benefits in having maybe two similar looking classes that follow similar patterns, because in the future you may want to refactor those in different ways, and if you combine them to a single class, it's going to be much harder to do that refactoring. So, but this, I'll kind of show you how this relates then to testing with interfaces. So, and this is again where Java 8 comes into play, because in Java 8 we get default implementations and interfaces. So here I have this, okay, yeah, testable, and I think I already have, okay, great. So here, pretty much I have testable is just taking in a value of what we're going to be testing, and this equal contract is going to be verifying that we have implemented equals correctly within a model. And this can be much easier then, and then here I have my test that's actually doing that, because telling developers oh, they're going to go through and actually test just to make sure equals works in all their models, that's going to be a lot of work. But here, this is a pretty simple test that they just have to run of just, create a couple instances of that model and to make sure they work. And so let's see if this test works. All right, so these tests, you know, it's just 2 methods here, but we're actually running 3 tests, and that's because in equals contract, we have these 3 tests that are actually being run. And you see the value does not, so I have 2 different values here, 2 different rooms, and the difference here is the room number, and the problem is in room, I implemented equals incorrectly. I forgot to include room number. So, you know, like I said, this, I can see the use, particularly at an architecture level, of having this. Like, you know, somebody sets up these kind of different contracts for maybe certain kinds of models or patterns that may be particular to your organization of things that should be done. And then just developers can kind of plug it in for like tests like these without having to go through a huge amount of repetition of like setting up these tests. Yeah, and then just so in the future. All right, so now equals is implemented correctly, and those tests pass. All right, next is filtering and disabling. So this is, again, some really vast improvements over JUnit 4, which really was not great at all when it came to these. The first is, let's just go into here. So before, if you want it, so like I said, we'll go with disabled stuff first. No longer is ignore, now it's disabled. Or, wait, yeah, I had right, disabled. So yeah, now if we try to run this, it will show as skipped. And just like before, you can also put this at the class level. So run here, and then of course they're going to show us all skipped. Now, you know, this kind of is annoying because with JUnit 4, this was just blanket. It was always ignored, always skipped. Now you can make this stuff more conditional. Let's just say, for example, you really just don't like Mac users, so you want to make sure their tests always fail, or give them a false sense of confidence. Well, you know, that kind of goes with Mac users. We're kind of arrogant people, so, you know. So yes, so pretty much what's going to happen here, it's going to, the extension context, you can actually get system, the system it's running on, in this case Mac OS X, and now I can go back in here and do disabled on Mac, and again, if I run this, they'll all be skipped, and this disabled condition, if I just were to change this to Windows or whatever, run this again, and now they all pass. And of course, there could be some real uses. Who here has heard of test containers? Has anybody used it? It's actually a really great tool. Unfortunately, it's not fully compatible yet with JUnit 5, so I couldn't quite show this test for here. But what test containers is it allows you to spin up Docker containers within your JUnit test here, like using class rules, so that we can spin it up and do like some integration test in a much more portable fashion. But for example, like I think Docker support on Windows has come a long way, but maybe there's some bug, or maybe there's some bug on Mac. You can put like disabled on Mac, so that way, you know, if you have different people using different types of systems, you don't have to be like, okay, like just ignore it that when IT customer repo fails because there's a bug in Docker on Mac or Linux or Windows or whatever. So that could be very useful. The other thing is filtering with tags. And wait, where was I? All right. Actually, I won't do it like that. I'll do it like this. So you can just do tag, and we'll just call this one a integration test, or just integration. And so I can run this, and because I don't have any tagging turned on, it will run. Eclipse has pretty good support for JUnit 5, and one of those things it does is you can set up tagging here and you can just say we're going to exclude all tests with the integration tag. We run this again. So the reason why it says no test found is because when you filter by tags, it does it eagerly, so it doesn't even attempt to run it like it would with disabled. But if I was to then run this up here, you'll see, test font, the reason. Run that again. Great. So now it's 14 tests, and tests find by valid room type is not even shown as a test on there. And then also what's cool is you can combine this tagging as well. So here, I'll create custom tags, just to say. So I just have tag integration and this interface and annotation. And so instead of having to do tag integration, I can just do integration. Code exists is so slow. Integration test, great. And then if I just run this again, I get the same results of 14 tests, and then test find by valid room type is not among those. All right. Okay, I think doing pretty much right, perfectly on time. So the last bit I'm going to cover is tooling support. So in my case, I was using Spring Tool Suite, which is based on Eclipse 4.7.1a, so you can see exactly how well Eclipse supports JUnit 5. If you're on IntelliJ, they've been supporting it since 2016.2, and I'm sure that support has gotten much better since then. NetBeans, I have no idea. And then for build tools, Gradle, I'm not a Gradle user, so I don't know the full support for Gradle. And then for Maven, they currently, unfortunately, support Surefire only. So that's really unfortunate for like integration tests. But I will actually show here in a second using filtering on kind of maybe a way to kind of a little bit get around that. You can't fully get around it just because failsafe offers like setup and teardown lifecycle that I don't know if Surefire offers that. Does anybody? Well, I do know at least failsafe offers that, and I don't think Surefire does. Anyways, let's kind of show what it's like to use Surefire in these tests. All right. And build plugins. Surefire. So, so you have to have these dependencies within here, within Surefire, for it to properly run. But all the same, let's just go ahead and give this a shot and see if everything runs properly. Maven test, and let's open up. Great, so everything runs. So, kind of what I was talking about, a possible way to kind of get around failsafe not working. I think support's going to come. I did kind of do some research on it. It looks like they're working on it. I don't know how high of a priority it is, so it might still be some time before failsafe is going to be supported. I could be wrong about that. It could be very soon. Is to use the tagging and filtering I showed earlier. So to do that, configuration or exclude tags. There we go. And actually, that's so here we're telling it to take in a argument from command line, and you can just do a little bit more easily than even with profiles. Not what I wanted. And just, I'll go and point this out here. So in this case, for like a CI build, we're going to tell it to exclude all tags with integration. And then for a nightly build, we're passing in none. Now, this has been fixed and so like I'm using 2.19.1 of Surfire, and it had a bug to where you can't just not pass a empty string into exclude or include tags. That's fixed in 2.20, but I was running into issues getting 2.20 of Surfire to run, so that may just been a mistake on my part and why that's not working, but that's already been fixed. So you shouldn't normally have to do like none. You can just actually simply not have anything in here, and that would work properly. But yeah, we can go on and just quickly show this. Whoops. Clean test, profile. What did I name that? CI build. I guess the only other thing you have to be careful of, if you are relying upon the failsafe plugin, so like failsafe looks for IT for integration test for test to run. You just, I guess, would need to change those class names back to test, so then Surfire would pick them up, or otherwise configure the Surfire plugin to actually look for those. But anyways, we ran 37 tests, and then if I was to run this again as Maven build, clean test, and then nightly build, we should get 38 tests. Awesome. Yep, 38 instead of 37. So we're getting that one integration test that we had tagged. All right. As always, behind every presentation, there's a whole lot of other people who've led the way. Definitely want to thank them down in the links. So a lot of stuff, like a couple of examples I just directly took from the JUnit 5 user guide. The assert all thing, I actually picked that up from that second link. And then I would also highly recommend this last link, CodeFX by Nikolai Parlog. He has a whole series on JUnit 5, which is really well done. The code for this course, I'll actually get I have like the initial state where I started this presentation. I'll get the completed state just loaded up here in a few seconds. There's also a video by Sam Brannon, who is one of the core committers from Spring 1. That was a really great presentation. Would definitely check it out. And again, that's just a link to my Pluralsight course because I'm self-promoting. Any questions? And again, if you think of a question much later, hit me at Billy Korando. Yes. Or okay.
What's your opinion on TestNG?
I used TestNG a long time ago. Like it's been like 6 or 7 years. I think it was fine. It did offer some of that like tagging and filtering support, if I remember correctly. I found JUnit to be a little bit cleaner in how you run it, so I kind of always just went with that. But if you like TestNG, keep going with TestNG. I'm not gonna. This isn't me saying TestNG is bad or anything. So. Until 5, yeah.
Until JUnit 5, if you had parameterized tests, TestNG was far superior. But
yeah.
And it also supported the assert throws.
Yeah.
But other than that, just those kind of things.
So yeah, I mean, yeah, clearly, like, yeah, that was part of the goal. Was also kind of getting that level of support also in JUnit 5.
So do I have to upgrade Spring applications from 4 to 5 in order to use JUnit 5, or?
So, and again, Mark, do you have much insight into that? I haven't quite tested it with JUnit 4. I do know they backported a lot of support to Spring 4.3. Now, definitely nothing before that. If you're like Spring 4.2, you may start running into some issues. Now, there's going to be a lot of things like, and I should be kind of clear in kind of what I'm saying with this. So, like this class, this would work just as well on Spring 2 as it would in Spring 5 because it's not really relying much on, it's not really relying at all on Spring anything. Where things may get more difficulty is kind of when you're kind of using like annotations like string JUnit config, if you're trying to do run with that stuff. And again, actually, I think you probably should be just fine because there's a lot of back-end support. You just wouldn't be able to take advantage of some of the JUnit 5 stuff. You can like, so like the class I just showed before, you can have that be all JUnit 5, but where you need to do like a run with or something, you just can keep that test class JUnit 4 still. So that's what you could do. Like I said, I think they backported a lot to Spring 4. I haven't tested it personally, so I can't say how great that is, but I do remember seeing that from a couple of presentations.
All right, thanks.
Yep. Any other questions? Yeah, just 1 minute, almost perfect timing. Nice.
Excellent.
Yeah.
Cool.
All right, well, if you have any other questions, feel free to grab me or, again, tweet at me. All right,
Thank you.
thanks.
Thank you.
Yep.